Hi everyone, this is Lahari studying in Sri Venkateshwara College of Engineering. Today's topic is Overview Assumption in Fault-Based Testing under the subject Software Testing. Introduction. Fault-based testing. It is a popular approach used in the software testing. It involves intentionally introducing the faults on the errors into the system. So we wantedly add the errors so as to test the software according to us it may work or may not work. So we will add the errors and check the software so it can eventually evaluate its performance under different conditions. The objective of the fault-based testing is to identify and fix the potential issues before they become a major problem that can affect the quality of the software product. Moving on to the overview, engineers study failures to understand how to prevent similar failures in the future. For example, failure of Tacoma Narrow Bridge in 1940 led to a new understanding of oscillations in a high wind and to introduction of the analysis to predict and prevent such distractive oscillations in a subsequent bridge design. The cause of an airline crash are likewise extensively studied, and when traced to a structural failure, they frequently result in the directive to apply diagnostic testing to all the aircrafts considered potentially vulnerable to the similar failures. Experience with the common software faults sometimes leads to improvements in the design methods and programming languages. So, for example, the main problem of the automatic memory management in Java is not to spare the programming the trouble of releasing unused memory, but to prevent the programming from making the memory management error and that frequently occurs in C and C++ programs. Of course, not all programmer errors falls into the class that they are prevented on a statistical detected. Using better programming languages, some faults must be detected through the testing, and there too we can use knowledge about the common faults to be more effective. The basic concept of the fault-based testing is to select the test cases that would distinguish the program under test from the alternative program that contains the hypothetical faults. Fault seeding can be used to evaluate the thoroughness of the test suite is an element of a test adequate criterion or for selecting test cases to augment a test suite or to estimate the number of faults in a program. Assumption in fault-based testing. The effectiveness of the fault-based testing depends on the quality of the fault module and some of the basic assumptions about the relation of the seeded faults to faults that might actually be present. In practice, the seeded faults are small synthetic changes like replacing one variable reference by another in an expression or changing a comparison from less than to less than equal to. We may hypothesize that these are representation of the faults actually present in the program. So, if the program under test has an actual fault, we can hypothesize that it differs from another corrected programs by only one small textual change. If so, then we need merely distinguish the program from all such small variants by selecting test cases for which either the original or the variant program fails. To ensure detection of all such cases for which either the original false, this is known as the competent program hypothesis, as assumption that the programmer under test is too close, in the sense that is of the textual differences, a correct program. Fault-based testing can guarantee fault detection only if the competent programmer hypothesis and coupling effect hypothesis hold. But guarantees are more than we expect from other approaches to distinguish and evaluating test suits, including the structural and the functional testing adequate criteria. Fault-based testing techniques can be useful even if we decline to take the leap of the faith required to fully accept their underlying assumption. What is essential is to recognize the dependency of these techniques and then interfaces about the software quality based on the fault-based testing, one of the quality of the fault model. This also implies that developing the better fault models based on the hard data about the real faults rather than guesses is a good investment of effort. Conclusion for the topic: fault-based testing is a powerful tool for improving the quality and reliability of the software applications. By deliberately introducing the faults to the system and testing the ability to detect and handle them, the developers can identify and fix the potential issues before they become a major critical problems. By following best practices and established guidelines, developers can maximize the effectiveness of the fault-based testing and ensure that their application met the highest standards of quality and reliability. Thank you all. Please do watch the complete video, like, share and subscribe.